Hello everyone, we will continue with the projections of solids. So now already we have understood the basic concepts of projection of planes. Now we will extend it to projections of solids. So as usual we will have in the orthographic projections, we have xy line. Let me start with the xy line. So I will draw the xy line first. Then I will name this x, y, vp, hp, because this is first angle projection, vp will be above, hp will be below. Now I will read out the problem. A square prism 35 mm side of base, 60 mm axis length rests on hp on one of its edges of the base which is inclined to VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 45 degree. This is the statement of the problem. Now we need to get the projections. So projections means here the top view and front view in the given condition. So we cannot do this final projection directly. So we will start with the no easy positions. From there onwards we will apply the projection rules and we will arrive at the final solution. Now, so already we have drawn the projection of planes. Now this is the we have some objects here. So these are the examples of the prisms. So these are square prisms. The reason is the top face and the base is the square. So here we have one more prism. We can see that this is a square. This is square means two square faces connected by rectangular faces. So these are lateral faces. So these rectangular lateral faces and this square faces constitute a square prism. So in square prisms we have these two lengths. These two lengths are equal, or we can say these four sides are equal because it's a square, while this height is not equal to the breadth and width. So that is what square prism is. While this is a special case where not only the breadth and width are same, also height is also equal to breadth, width and thickness. So here this becomes a cube. However, cube is a square prism, while all square prisms need not be cube. Now we will go for the projection of the square prism. Now as we know in orthographic projection we have two views, that is top view and front view, and also side view, but we are not going to draw that side view. Right now we will concentrate on top view and front view. So to get top view, the observer has to see from the top, or we can say that the projection on HP, horizontal plane. To get the front view, observer has to see from front, or the projection on VP or on the wall. So now let's start with the projection of the projection on the HP, that means the top view. If the observer sees from here, now we will keep it in such a position that where he can see or where he can draw easily the projections. So in this position observer can imagine easily and draw the projections. So if we see from top, so now what he can see is the top face. So the top face is named as A, B, C, D, the naming. So now when the observer sees, the projection will be, we will get a square. So that square we have to write it here, draw it here. Now this in the problem he has given 35 mm side of base, means so the dimensions 35, while the height, axis length height is, this is actually side, but axis also in the prism's axis length is also equal to the lateral side length. So which happens to be 60 mm in this problem. Now when you are solving in the sheet, you will be taking these dimensions only. If I use those dimensions, it will not be visible properly. So on a bigger screen what we have here, I am going to scale up, that is by taking the 4 times size of this I will be drawing it. But when you are doing, or when you are drawing in your sheet, you have to use the given dimensions only. So now we will start. So now, so 35 will become 140, 60 will become 240. means 4 times scaling up. 35 to 4, 140, 16 to 4, 240. Now, I will be taking this. So, for a top view, so now what I am seeing, so on the top view, how the projection we get on the floor. So, we will be getting the projection of this point, this point, this point. If I draw, we will get a square there. That means after getting this, we will rotate it. Means we are going to get on the HP. That's the basic concept already. You know it and you have learned it on the in the projection of planes. Now, what I will be getting? So, in the top view, I will see this dimension and this dimension. That or I will say take this dimension. I will be seeing in the top view. I will be seeing these two dimensions. Means 35 into 35. Here I will be drawing it as 140 and 140. So now we have to take one care. Now when I am drawing the first one, I should be seeing that the top line. First I will draw a reference line which will be perpendicular to the XY line. Then I will be drawing 140. The why 140? Because 35 to 4. That's what I am drawing. Now, once again, we have to be careful. This angle should be 90 degree. So, then once again, this angle should be 90 degree. You have to take care of that. If you have properly taken 90 degrees, the last side when you join, this will also be exactly 140. Otherwise, you will see the difference. And also, when you have taken 90 degrees here, these two lines will be parallel. Now, so what we draw is what we have drawn here is the projection of the top face. That is, see here, if just I rotate, I get this point A, this point B, this point C, this point D. Apart from that, when the observe from the top, there is a face below also, which is not seen. However, the face is there. That is the difference between the projection of planes and projection of solids. Now, what are they? They are A1, B1, C1, D1. Well below A, A1, B, below B, B1, below C, C1, below D, D. So, these are the points are there, but which are hidden. So, that's why I will be naming them in bracket B, B1, C, C1, D, D1, A1. So, now that's what the difference. In the place you would have just got ABCD, but we have got here 4 points, the 4 corners plus 4 corners, total 8 corners. Next, we want to get to the front view. To get the front view, observer will be seen from here. So, what he sees, or what the projection we will be getting on the wall. Above this is wall, below this is the floor, which is rotated and has become like this. The floor has been rotated this way. Now, when the observer sees from here, you will be seeing this space. While these spaces being perpendicular, he can't see, and the face behind is also hidden by this space. So, what I will be seeing is this space, or because it's a cube, we can see here. We can see the height. This rectangular face we can see. That is AB, B1, A1, A. This rectangular face I will be seeing. So, that means I will be getting the projection. I will be taking this point above. So, already I have taken this point. So, now, because in case of prisms, the axis length means from the centroid of the bottom face to the centroid of the top face is also equal to the side length. This is the advantage. So, easily we can draw the front view or the rectangular face. So, I will take this axis length. So, that happens to be 240 here. Then I will join now. So, what are the names? Let's see. When we see from here, what we can see is A here, What you can see in the front view is B here. What you can see is B1. What you can see is A1. So the face seen is A, B, B1, A1. Then also apart from these four corners, we have the other four corners which are D, C, C1, D1. So which are hidden. So that's why I will call them as this as B1, C1. Here it is B in bracket C, A in bracket B, A1 in bracket D1. So I just repeat, in the front view you can see A, B, B1, A1, while we can't see D which is behind A. So which is in bracket, you can see A in bracket B, because you can see A, you can't see B. You can see B, you can't see point C, so that's why I have typed in C. Similarly, you can see B1, you can't see C1. That's why B1 out of bracket, C1 in bracket. While A1 out of bracket which is C, and the D1 which is hidden is in bracket. So, okay, now we have drawn these points, but one thing here we need to observe is there is no difference in these naming. Means here also we have used B, here also we have used B. What is the difference? Actually, this is front view, this is top view. Just I explained what are the points of the corner C which are hidden. Now, because these are front views, we have to use B1 dash, C1 dash, B dash, C dash, A dash, B dash, B1 dash, B1. Means when I use this with the dash, so this says that this is front view. When I say, when I use the alphabets without dash, means they are representing the top view. So that we have to remember. Next, after that, how to draw the axis. Now we have not shown the axis. Even without the axis also we can go through this problem, but in some problems the location of axis is required. So however, it is very important to represent the location of the axis. So how to get the axis? So get the diagonal of the top. These diagonal lines should be thin, while this part should be thick. These are projection lines, this part should be thin, and these diagonal lines are construction lines, they should be thin, while this part should be thick and dark lines. And here in this part, these are the lines to be dark and thick. Now, some people sometimes miss this part. However, please remember to join this part, because this is also one edge. These are represent these edges. So, without forgetting them, join, make this part thick and dark. Now, axis will be like this line should also be thin. And the convention for the axis line is chain line, longer line, smaller line, gap with a gap. So this is the convention. And because the axis is an imaginary line, this should be a thin line. Now, yes. Now we constructed this top view and front view. So now let's know. I could have drawn this diagram this way also. For example, if I had kept this way and drawn it, I would have drawn the top view like this, for example. So, why did I go for this particularly? Because of the condition given. What he is saying is, the square prism is resting on side of the base. That's why I have taken the edge position or the side position. So, there is one more type called corner resting or corner resting position. So, now, because this is the case of edge resting or the side resting position. Now, so coming to, we position in this sense. So we can see this face in the front view. Now, but in the problem what he has asked is totally a different thing. Why we have started with this? Because this is the easy position which can be easily imagined and we can draw the projection. Now, next let's try to achieve one by one the two conditions one by one. So first condition is what he is saying, it is resting on one of the edges of the base. So resting on the edge, and then one more condition is that edge is making an angle 45 degree with HP the axis is inclined to HP at 45 degree. Now, right now take the condition. So the axis is perpendicular to HP. The axis is perpendicular to HP. So the condition it is not according to the given condition. So now let's modify to get the second condition to achieve the one condition. So that means what I will be doing is I will take this, I will rotate this way so that we are achieving two conditions. So the solid is resting on the edge on HP and also the axis will be inclined. Now how much it should be inclined, that is given. It should be inclined to HP at 45 degree. So means the axis should be inclined to 45 degree. That means that this axis should be inclined to the HP. The axis should be inclined to HP at 45 degree. Means I will be from the vertical position of the axis, I will make it inclined to HP at 45 degree. So which you can see in the front view. Now in doing so, I am not changing the shadow of the front view or shadow on the wall front view, just I am rotating this. So I am going to reconstruct this in the second position. So how I will do it? So the same diagram should be reconstructed here such that the axis should be inclined to XY line at 45 degree. So however, we can use a trick here. What is the trick? This edge and the axis are parallel to each other. So if I make this edge 45 degree to 45 XY line, automatically the axis will also become 45 degree to XY line. I will make use of this condition. So I will locate a point here B1 dash bracket C1 dash. This point I will be taking, and I will be measuring an angle of 45 degree. I will be measuring an angle of 45 degree. This is the reference point. You can take any point here on the XY line. You see that after reconstructing, the diagram will not be overlapping on the first one, and it should not be too much distance. If you take too much distance, the next position may go out of the page. Take care of that. You can take any arbitrary point. Now I will join this line with a very line. Okay. Then I will measure whatever this length. Already I know that is 240. I will be measuring that here. 240. I will make this point. See. To get the angle, I would have drawn the line up to whatever the length, but I need to make only thick up to 240 length. Now, reconstructing. So, we can use different methods. So, one of the methods I will be telling, I know this angle 90 degree. So, you can take this angle here 90 degree and draw a line. This is one technique. Or the generalized technique I will be telling. So, what I do, I have got this point. And already we have drawn this length here, we have got it here. So 2 points, once we get 2 points, that means B1, C1 dash. Here I have got this point as B dash, C dash. So now what I do, I will take this length. And cut an arc here. Then I take this length and cut an arc here. So this is not interesting. This you get by experience. So go back here and get this, and from here. So now what I did was, okay, now what I tried was, to get the location of this point means that point is B1 dash in bracket A1 dash. So however, okay, sorry, this is B1 dash. So what I did was I had these 2 points already located. I took the length from this side and drew an arc, and then I took the length from this point and drew another arc. So the intersection gives me this point. Similarly, I want to locate this point. So what I do, I take this length. Okay. So from which point? B1. So here B1 as center, I draw an arc. Then now it is up to me to choose any point, whether this point or this point. Both points are there. So let me take this point. So now I take this distance and draw an arc here. So this point is B dash, B1 dash in bracket, sorry, B1 dash in bracket and B1 dash. Now what I do is I will join both points. So this is the reconstruction of this diagram here. At the moment, I will also take these points. So the naming are O1 and O dash. So here it is O dash, O dash in bracket O1. So this point is O dash, this point is O1 dash, because okay, now sorry, I'll be explaining this. So see here, when we see from the top, we can see the point O, that is the center of the top face. So that will be out of bracket, I'm sorry. Then the center of the bottom face is O1 dash, so which will be not seen. So that's why it is O1 dash. So in the front view, okay, now the center of the top face is O, so which is seen in the top view. I'm sorry that I have drawn a dash here. So in the top view, we will be having only O, and the center of the bottom face is O1. So this is also in the top view, we don't get dash. So then here in the front view, though it is the top face or the bottom face, both are hidden, or we can see this only this time. We can't see the centroid. So that's why they are in bracket. So the reconstruction as it is, no changes. Every point as there, we have to draw it. So this is what we are going to get. So there is one more mistake. I will correct it. So this is what is the right thing. Okay. Now, so in the next position, I will be drawing the top view. So here we got the front view in this case. So we started from here, we rotated it like this, making the axis inclined 45 degree to HP. Now we got the front view. Now how to draw the top view? So the top view will be, we will use the drawing techniques and do it. So now, so to get that, we will be drawing the horizontal projection lines and vertical projection lines. So let me draw those things. Then okay. Now to get the top view, we will be having the horizontal and vertical projection lines. So let me draw the horizontal projection lines. So these are the horizontal projection lines. Next, vertical projection lines. Remember, these projection lines should be thin and light. Then I will be drawing, I will be starting from here. So from B dash. So where is this point is, though it is dash, is B, and from here B. So intersection of these two will be here. So this point is B. Next, from C, this point is C. Next is from D, this is the new D. Then from A1, this is A1. Sorry, this is A. Next from A. Then similarly from B1, this is new B1. From C1, this is new C1. Similarly, from A1, new A1. From D1, D1. Now, if you want, you can also draw this is O, this is O1. Now we have got the projection points. Now we need to join them. Here is the new thing what we need to learn in the solids. So as we have seen here, there are some points which are in bracket, out of bracket, because we know that properly what are the seen corners and not unseen corners or hidden corners. Now after rotating this, what we see is, if the observer sees from the top, I am just rotating to make it visible to the observer, so that this face, if the top view, if the observer sees, he can see this face, and which was hidden in the first position is now seen now. So these are the changes we need to incorporate. So here we will have some rules. According to that rules, we will join the lines. So here we will get two types of lines. One is visible line and hidden line. The lines, the convention for visible lines is dark and thick. The convention for the hidden lines are dark but discontinuous. There is a difference between this line and this line. You have to see, this is a discontinuous line. So here you can see this as a chain line. Now, and axis line is chain line and thin line, while hidden edge is a dark line and discontinuous line. Now, the first rule is all boundary lines are visible. This is the first condition. So according to that, we need to join all the boundary lines. Boundary lines means this line, then this line, this is the boundary. So all the boundary lines are visible lines. Now, to get the top view, observer is seen from here. Means after rotating in the top view, observer is seen from this face is visible. Means all the sides of visible face are visible. So according to that, now visible face is ABCD, means top face. ABCD is the visible face. Now all the edges, already we have got 3 edges joined, so the third edge will also make this visible. Next, when the observer is seen from here, this face is hidden face, or I can say this face. If you see from the top, this face is hidden. So except the next is for first one is boundary lines, second one is the sides of a visible face, next is the sides of a hidden face or invisible face. So here in this problem, A1, B1, C1, D1 is the hidden face. So for that, the condition is except boundary lines except boundary lines, because for boundary lines already the condition is satisfied. The except boundary lines, other sides of hidden face are hidden lines. I repeat, except boundary lines, that means D1, C1, D1, A1, B1, A1, D1. These three lines are boundary lines. They are visible according to the first condition. So now, for a face A1, B1, C1, D1, D1, A1. So three sides have been already the boundary lines. Now the remaining only one side, that is B1, C1. That should be joined by a hidden line. The reason is because A1, B1, C1, D1 is a hidden face. So this part of the line is hidden. So see, while if I had drawn this line, projection line, thin line, I can make a clear difference between this part of the line as thick line. Now, so this is what we have to see is, have we joined all the lines? That is, how many edges we have here? 4, 8 plus 1, 2, 3, 4. Total 12 edges are there. So all the 12 edges are joined. We have to see, look for that. So see, let's say A1, B1, B1, C1, C1, D1, B1, A1, 4 edges done. Then AB, BC, CD, DA, 4 edges have been joined. Now A1A, B1B, C1C, D1D joined. Now you may ask questions, there are no so many lines. So they are different lines because they are overlapping. The one line is overlapping over the other. They are drawn on the same line. Next is, we have to move to the next condition. Before that, yes. So we need to go for the third question. Yes, we already there is one point to be expanded. That is O1. O is the axis which is already drawn. So you can just make, this is also thin line, just make a join to A1 to 1, which is axis. Now, okay, now we achieved one condition, that is, we made the axis of the prism inclined to HP at 45 degree. Let's see, is this one more condition is already achieved or not? Now when we rotated this from this position, we rotated it like this, so one condition is achieved. Second one is, now there is one more condition given. What is that? The edge on which it is resting. The edge on which it is resting is B1, C1. This edge, B1, C1, on which that is, it is seen as a point in the front view. It is seen as B1, C1. So this B1, C1 should be inclined to VP at 30 degree. But right now, if you see what we observe here is the B1, C1, the edge on which it is resting is perpendicular to VP. That's why we are seeing it as a point in the front view. Also, we can see it here in the top view that it is perpendicular to VP. Now, I want to make this inclined to VP at an angle 30 degree. So what I will do is, I will rotate this such that till this angle becomes 45 degree to 30 degree to VP. So I will rotate. It is like this right now, in this way. So now I rotate it such a way that this edge, if I extend, it will intersect the VP at 30 degree. Now, in between, please recall a point that for a line, the inclination of a line with respect to VP is seen in HP. The inclination of a line with respect to HP is seen in VP. That's why the axis inclination is given with respect to HP, which is seen here. Angle, this angle is 45 degree, or you can extend it here. This angle is also 45 degree. So this is the inclination with respect to HP. While we are next going to draw the inclination with respect to VP, which will be seen in HP. So now, which is the edge we are talking about? That is B1, C1. That line should be inclined to VP at 30 degree, means inclined to XY line at 30 degree. So now I will take the protractor, I will take a arbitrary point. Arbitrary point here. I'll measure an angle of 30 degree. So here we have to be careful. This comes with the experience. So if I take the line 30 degree here, I have to see that the line B1 C1 comes on this line, and I reconstruct the diagram. If I simply do right now and proceed, I may end up in situation such that this diagram, some of the part may come above the x value. So, or if I take too much this side, the diagram may go out of the page. So, with the practice it comes, we can have an idea. So now I can't draw it here. If I had drawn this here, for example here, 30 degree line, I could have got the diagram here properly, but the diagram may go out of the page. So we have to look for that. Now, however, I will make a trick here. That means, see, B1 C1 is parallel to A1 C1. Either way you can draw. You can draw this point here, B1 C1 on this line, or A1 D1 on this line. Both are right. However, to avoid confusion, what I will do is I redraw it and okay, I will take 30 degree line now. The reference point here I will take 30 degree line. And now I will be reconstructing this diagram such that B1 C1 is on this line. So I will mark some point here as B1. I will take this length B1 C1, I will mark it here. This will be C. Now observe here, if C1 D1, I take here C1 D. Now I take B1 D1. Let me see whether it will cross x y line or not. See, we got the point here, just below the x y line. So if in case it goes x y line, we have to be careful that we have to draw this here and take that some distance below. Next is to get A1. So we can take B1 A1, B1 A1, then C1 A1. This point is A1, A1 D1 C1. Then now B1 B, B1 B. You can also see B1 B is equals to C1 C. So at the same moment I will draw one more arc here. Then I take B1 C, which is also equal to C1 B. So B1 as center I will cut an arc, C1 as center I will cut another arc. So I am getting this point as B, this point as C. Now I will join those. Now I didn't go for A and D because to save the time, because when I locate the B, A will come on the same line. So I'll just take this distance now. I'll take this distance, which is these two are equal. I'll mark those 2 points. So B1, this is A, this is B. Now, this is reference line already drawn. Now, however, this is a hidden line, so I should make this line also hidden. Now, if you want, you can just take these two points, these two are equal. So, to locate. Similarly here, B2O and C2O. So this point is O, O1 and now next step is to get this is the top view. What we observe here is, why I drew like this is, after first step, second step. So when I rotate it like this, the shadow on the floor didn't change, it just rotated. Means its shape and size didn't change. So I am reconstructing this diagram as it is here, only I am making the orientation shifted. So next is, however, in the front view was this way. Now after this, we can see that how it is seen to observer from the front is different. So how to get that? So to get that, we will be taking the projection lines. As usual, horizontal and vertical projection lines. Now it's better to see the particular point and draw it. So now it is A1. Where is A1 here? Here. So instead of drawing unnecessarily extra line, I will approximately draw up to this lines. Then from here, so this point is A1 dash. Next is B1. Where is B1? B1 is here on the XY line itself. So I am getting this point as B1 dash. Next, A is there. A is here. I will be drawing. From A, this point is A dash. Then A1 dash, B1 dash, A dash, B. B is here, so I will be drawing a line here. So this is B dash. Next is C. C is on the same line, so I will extend this line. So this is C dash. Now D is on the same line as A. This. So this is B dash. Now C1. C1 is also on the XY line. So this is C1 dash. Now have you got all the points? A1, B1, C1. A, B, C, D we have got, but we have not got D1. So D1 is from here, whereas D1 is from here. So from this point, D1 dash. Now here, because as we have got many points and so many lines, I will use some color chart so that just to make the joining lines to be in a different color. In the normal drawing, you can use the normal pencil only. You did not go for any colors pencils. Now let's try to join the lines. Now as usual, the first already I had written the laws or the rules. So first rule, all the boundary lines are visible lines. So now what are the, let's say A1 dash, let me join A1 dash to B1 dash, then B1 dash to C1 dash, then C1 dash to C dash, then C dash to D dash, D dash to A dash, A dash to A1 dash. to join the lines if they are real edge. For example, see, AB is a real edge, BB1 is a real edge, while AB1 is not a real edge. BB1 is a real edge, AB is a real edge, AB1 is not a real edge. So AA1 is a real edge. Now we can see AA1, BB1, we have not joined, no problem. Now C1C, real edge. CD, C and D, CD is a real edge. DA is a real edge. So all the lines I have joined are real edges. This is one condition. Simply I can't join any points I want. They should be real edges. Second thing, I have said it is I am first getting the boundary. When I am saying the boundary, when I draw the boundary, all other points what I have got should be inside the boundary. We have to take care of such a way. And we will be getting some in future some problems where you may get some confusion. There we will explain the other details. Now first condition is satisfied, that is all the boundary lines are visible lines. Second is to get one visible face we need to let's try to see. If you see, that means after first step we started from here, we started from like this, means ABCD was vision. Now we rotated it like this. Now after this we rotate it like this. So it depends upon how we have rotated. So now for the front view, observer will be here and he will be seeing, he can see this face, that is ABCD, while he can't see this face. Very simple way, a crude technique is, from here if the observer sees which is the near face, ABCD or A1, B1, C1, D1. Here it is obvious that ABCD is the nearer face, so that will be visible in the front view. It is irrespective of this here top view. In the top view it may be visible or hidden. Just you have to see which is near to this arrow or the observer. So for the observer ABCD is the near face, so it will be visible in the front view. Now, so let's join. What is the rule for the visible face? All the edges of the visible face are visible lines. So A, B, C, D, already A, D, B, C are joined. So now I will be joining A, B and B, C. These are also visible edges. The reason is these are the edges of a visible face. Next, now coming to the other face, that is A, B, C, A1, B1, C1, D1, which is away from the observer. So it is a hidden face. For the hidden face, the rule is already been told, that is except boundary lines. Except boundary lines means A1, B1, A1, B1 and B1, C1. Already they are boundary lines. The remaining two lines A1, B1, B1, C1. Those two lines are hidden lines. So I will be joining by this way. Next, so now we have joined. See, is the problem completed? No. The reason is there are some edges still to be joined. What are they? D1, D, B, B1. Other edges have been already joined. Now, how to join these two edges? There are some more rules to be known. So that is, if a line is starting from the end or the boundary of a visible face, that line will be a visible line. Or in some teachers tell it like this: the line going outside the visible face are visible lines. Means because it is starting at the end, it is not coming inside the visible face. So from here I am going to join BB1, which will be a visible line. The reason being it is going out of the visible face. Now if I want to join BB1, we can easily see that it is going inside a visible face. So that's why opposite. If a line is going inside a visible face, it is hidden line. If a line is going outside a visible face, it's a visible line. So using that rule, so I join this way. So D1 dash D dash is a hidden line. So now this is the completion of the problem. However, if you want, you can just draw the position of the axis so this is O dash O1 dash, so you can this color combination is only to make the clear visibility. There is no need or not required to draw with different colors, only the black color. So now after drawing this, we can see that we have completed the problem. Just we can see that why we need to do this is because all the edges are not visible. So here in the new thing in projection of solids is to learn to draw which are the visible lines and which are the hidden lines. So I think we have completed this problem right now.